So where are we at? That hurts. Tea time. Oh, where's my spoon? I don't need my spoon. Oh, it's so full. Oh, what was that? Already lost one mug, I don't want to lose another one. No, 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 don't spill. Oh, it spilled. Yes, this is a good stream. As always. Top quality only. Build some tea. Oh, there we go. Oh. So, where are we right now? We play it. And we get a bunch of colors. Now, this is actually kind of incorrect. I realized like this morning. And it's actually kind of annoying. Because fixing it would require sacrificing 4 bits. See, what's happening is that I give every single voxel a volume. And then I calculate the volume on each voxel for the sides based on the voxel and the voxel in that direction's volume. But the problem is, I think, well, yeah, it's still a problem, I think. Well, is it? No, it's not. But it's still kind of odd. This one, for example, this one is strange. And it's also strange strange what we're getting too, isn't it? Now, right is red. So that side in the middle there and this orange side, these two sides are horizontal. So that means left and right. Forward and back is blue, so that's the Z. But see what's weird here, if this is the right voxel that we're even looking at right now. Looks like it. If left is 7 and forward is 7, and center is 1? Is this how it should look? Don't think so. What about down here then? This is not a surface. That is a surface. And here again, 7, 7, 7, 0 even. 0? How can it be 0? How can it be 0? Well, no, 0 is supposed to be something. It's still weird. Isn't it? Yeah. How does this work? So what I'm doing here is to get this edge. If we enter on Z, then I check the I check left and I check right. Hello, Robert. And then I take our Z value. And I take the Y value, or I take the X value, which is left and right, and I add those together. And then I divide them by 2. That's why we get... That's why we get that. Let's look at that. Let's look at the code, because what's missing here for sure is that it's not taking the middle into account, because the middle is down there. So actually this would look something like center is right here. That's center, more or less. Maybe there, maybe there. And then we have left is 7 here. The left should go like this, rather. Like that. But because we have this centerpiece here, it should be even further. It should be like this. It should go like that. And then down like that. That's what it should look like. And the same should happen here. It should go down there. And then there. Like that. And these shouldn't exist. Like, this shouldn't be a thing. I think... Yeah, because, like... you have to take into account... No, these would not exist. This wouldn't be a real slope. This would be like this. This is how this should be. And then here, this should all be white. In fact, all we should see there is white. Because this should be more or less whenever we enter and we exit a side, what we should check is if we like exit above like the center or not. I wonder if this approach of checking the exit is wrong. No, not exactly. This is how it's supposed to be, more or less. But it's still not good. Because if you look below, you see this purple cube here. This purple cube is a non-surface cube. And that means that it's just always perfectly square. So this is actually a surface cube that's meant to like deform, to smoothen out this step here. But this is just going to be like that until I figure out how to smooth that after I figure this out. And I think I might. Yeah, we probably will do that, because here we can also figure out how big like this cube should be by like basically just moving this corner inwards based on how much this cube has in it. Because right now, this cube has 0 center, 0 right. Oh yeah, I remember 0 right also means that there's still something there, kind of. But it also doesn't. Man, does this make sense? Maybe we need to go back to 0, meaning it's just cold entirely. But like this to me, kind of weird. Maybe not. Either way. Let's make sure we turn these off. Yeah. I don't like writing debug logs that much. It uses up all my space on C:. Anyway, let's go look at the math. Now, the one thing that I am quite certain is wrong is this here. Maybe not. I mean, yes. See, the problem is because we have a center point, instead of doing this here, right, where we have this side's height and then we check that side's height, it actually has to be more like this. And we've got the center point there. And then we check this side's height, which in this case is supposed to be 7, which is up here. So this is actually wrong too, over here. This is wrong. Think. But not really as well. Because... no, it's not wrong. It's fine. Kind of. But regardless, this should go from here, to the middle. And then we should check from here to here. That's how it should work. So if this instead of 0 is like 5 or something, then it would go from here to here. That or something. Right. And then this would go like that to that. To that. And you might think, well, that looks stupid. Like now you basically have a square area here, right? And you would be correct. However, the idea is that once I have this, or once I have this working, this should be smoothed. I don't know exactly how we do that, but this should not be, it should not be like this. This should be a curve that goes like that. Same here, like that, like that. Like so. And that way we get like a smooth curve there, more or less. But I mean, it's still obviously not great. So now here you have sharp edges. Sharp edges. And but I'm not entirely sure about how to do it there, but we'll figure something out. Because here now, we also have to figure out, like, if, and that's what I haven't written yet, if we hit the center, like, this needs to be filled out. And that's where this is going to come in, because this is also going to be, like, curved like this, right? So hopefully we can get somewhat of a smoothed shape. And then comes... And now, I've kind of made this a little bit deceptive here, because this would never be this high. Well, it could. Yeah, it would. If this is just high enough, then this would look like this. But we'll deal with that one step at a time. I'm not exactly sure what I'm doing. But we need to do something here, because here first, well, as we're ray tracing, we check the ray step x equals 1 here, and that, or that's when we enter the cube. We check the entry mask. If ray step x equals 1, meaning we enter on the left side, because this is a ray that is traversing positive to the right. That means whatever we hit was on the left side. Then here I just calculate. I take the left and I take the right. Is this what's wrong? How do we correctly calculate the entry? what I'm doing now is I'm taking this side here plus this side, which should be up here, and then I add them together, and then I divide them by 2. So in this case, that's why it starts where it starts. It starts there because this side is 7 and this side is 0. So when I add those together, or rather, this side is 8 and this side is 1. That's what it actually means. So when I add those together and I divide by 2, well, that also doesn't make sense. Then we get a 9. But I mean, that's kind of correct. We get a 9 divided by 2. That's 4.5. So this side is a 4.5. And I guess that makes sense, because otherwise, like, I need to calculate an entry here. But but this entry is 0. So what we need to do is we need to add what we're doing here, midpoint uv.z. But what we need to do is we need to do here, as we enter, we need to check if entry uv.z is less than 0.5. Else. So if this is less than 0.5, I'm gonna copy this over there. If this is less than 0.5, then we still want the left here to be left plus back, but the right should be left plus center. Times 0.5. And then here you also need to do this differently. So as we're less than 0.5, then we need to do entry UV Z times 2 else you do minus 0.5 times 2. And the reason for that is we still want... Hold on, that's too loud. What we're doing is we're using the entry point, which is a 0 to 1, to determine where along the cube we are at. And and what we're doing here is we're creating we're getting the height on the left and the height on the right, and then we use our entry point in this direction to determine where along this value we are. So if this is 0 and this is 1, then if we enter over here at like 0.3, then we get that point between those two values, right? But since now we are doing we're adding a center point, that means that we have 2 points, but we only have one entry value, which is 0 to 1. That means we have to convert 0 to 0.5 in the entry UV to 0 to 1. And you do that by just multiplying it by 2. Because then if you're at 0.5, it's multiplied by 2. Like that's its max value, so now it's actually 1. But if it starts at 0.5 and it goes to 1, then you have to subtract 0.5 and then multiply it by 2 to get 0 to 1. And then here we have to say left plus back, left plus center, and here it's going to be left plus center and left plus forward. And now, this is where things get a little bit tricky. I'm not really sure how to calculate this. But it's not... There we go. Here we have something. Now we've got the reds behaving a little bit better. But I'm a little bit upset at them as well. Can we not find... Why are they all 0? And this one is not 0. So why is it not the way it's supposed to be? Here you've got back 7. And you've got forward 3 even. So why is this one, the red one, just doing this? I'm gonna do this. This is a good thing to do. You copy the component as you're playing, and then you stop playing, and then you paste the values. Then if you start where you left off, right? And you see I've got some brown in there. And it almost kind of does what it's supposed to, but it also doesn't. It's actually filling up the triangle, but it's supposed to do that more from the middle, and here it's just kind of filling up the inside of it, which is not right. But anyway. Entry UV. Left plus back. Let's keep it playing. So here we are starting at left. Alright, okay, so we start at left and do left plus back, which is 7. And this is left, so that means that this is red. So this is left, but doesn't that mean that this is back? Why does that say 7? This is back. Right? We've got left here, we've got right there. That means this is forward, and this is back. Could I be setting this incorrectly? We could be. Or reading it incorrectly? No. How confusing is this? Let's take a look at if we do this. Does that change all the colors? No, but it flips it. That explains it. Okay, so it's actually correct. It's just that my FOV is negative. It flips all of it. I don't like that. But I don't think it really matters. All I have to do is change my controls now. And over here we have horizontal, yet axis raw. Negative. And input X also negative. Is that good enough? No. What did I just do? Oh, horizontal goes there, and left and right is right now, but up and down is inverted, so we need to invert that too. Horizontal, I guess, does not need to be inverted. Yeah, now it works again. Right. Now we can go back to figuring this out. Except... Let's see. Here in our brick map controller, we are checking hand rotation times vector 3 forward, but that should now be vector 3 back, which is also I'm not really sure what the best approach is, because what you could do, I guess, is if flipping the FOV to negative makes that happen, then we could just flip the horizontal view. So I'm not entirely sure like in here at the beginning. Well, I'm not doing it here. I'm doing it downstairs now. Here. We have a camera plane, which is 1, 1. So could I flip this to negative? Like that? I'm not sure what I would do here. I don't feel like that makes sense. Because here we do camera plane V, screen position Y, ray direction. I don't know if that would flip it. But we could try cs test.x. Here's cs test.x. Yeah, that flips it. So if we set the FOV back to -8, and then we turn around and we have the horizontal set to negative there, then it's correct and we can still use forward. But then again, if I'm standing here, what are we getting here? That's blue 1, red 0.5. Here. So we are getting forward. Yeah, so if we're standing here, we get forward, and on the left we have left, and on the right we have right. So this feels like the way it should be. Yeah? But what was the issue? Well, I'm not sure there is an issue. There should be. Well, I think this side should be... This should be left, and this should be back plus center. Then this should be back plus center, and this should be forward. Not quite. Oh yeah. We have to fix everything we ruined. So now... Well... I think the mouse horizontal still needs to be flipped. Yeah, and now horizontal movement also needs to be flipped. There. And in here, we need to switch this back to forward to check ahead of us for a voxel so we can read it. Come on. There we go. So now we have a center 6 there. But forward, supposed to be a 3. So left is 0. It starts at left times 0.5 is probably not right, but this is wrong. What I had in mind was it starts at back, and then this should be left plus center divided by 2. And then here it starts at left plus center and it ends at forward. That was the idea. But now it's still exactly the same as it was before. Oh, the forward multiplied by 0.5. That's also... Now that starts up there. Good. But it's still not... It's still not respecting the 3 there for the forward. Because left is 0, right? And the center is 6. So if this is left plus center divided by 0.5, that should be a 3. It starts at back, which is 7, and it goes to left plus center, which is towards us plus the center, which is 0 plus 6 divided by 2, which is 3. And then here, when we... This is if the entry uv.z is greater than 0.5, then we start at left plus center times 0.5, and we move towards forward, which is 0.3. Which also doesn't work. So... which part of it is broken? Let's do the actual math here. So if we have back 7, left 0 plus center 6 divided by 2 equals 3. And then to calculate the height, we take y min max plus y min max x. So that's gonna be 3 minus 7 equals minus 4. And then we take 7 plus entry uv.z, which is, let's say, 0.32 times 2 times y minus 4. No. Times 3 minus 7, which again is -4. I don't really see an issue. Why does it go straight down? This is very strange. This doesn't do anything. How is that possible? now it goes up when I add a plus. So it's actually 0. That's super strange. I'll be right back. This is wrong. This needs to be float. All of these should be floats. I don't know how it even works. There we go. Now we're getting somewhere. Yeah, see, now we're getting actual values. Not just half values and full values and zeros. Now we're getting actual values, the way it's supposed to be. And you see here now, we get little like curves and slopes and whatnot. And here it's even like this, you know. It's higher in the middle than it is on each side. Here. I don't know if this is going to work in practice, but this was the idea I had, and I kind of like going for an idea, and just see what happens. So it can be kind of nice to just think of a solution on your own, and it can have just completely different outcomes than just going with the canned solution that you've already got. All right. So now that works. That means we have to do this everywhere. Which sounds a little tedious, and that would be correct. Now, yeah, this should be right. That. In fact, I'm gonna put it on the left or on my other screen here. Because I cannot keep track otherwise. There, and then this midpoint thing, not sure exactly what should go there. Let's. I also want to type. This is left entry. Or we should say like that. Left. If this is left entry, that means this is right entry. And then here we got right plus back. How does that make sense? If we enter left, if we start it back there, then we can't start it back on the right. That makes no sense. This has to be forward. But no, it doesn't work like that. That's what I found so confusing. Here it starts at back and goes to center. Then if it's over here, then it should start at front and go to right. But that's not the case. That's because we are using Z. And Z goes in that direction. That's why. It's because the Z is the same value. A little bit confusing, but that should be how it works. Yeah, see, now we have it on this side too. Yeah, I don't want to deal with the midpoint. Let's figure that out later. Else, if entry mask equals y, then raise step y. This should be forward. No, this is above entry. Now, I don't know if I need to do anything in the above entry at any point. I feel like I should, though. But I'm not so sure. Because what I might need to know is where we hit the ground. Because otherwise I can't calculate rays for lighting. So that might be very necessary, unless instead of calculating lighting per pixel, I calculate lighting per block, which I'm not so sure I want to do, but I might. Because you can calculate lighting per block and then still adjust it, kind of, so that it's not the same across the entire block, and then you can probably get it to look the same anyway. So then here now, below entry. No, this is below entry, and this is above entry. And what I'm doing here is I just check if we enter from above, and then I check if we exit from below. And then I just break there. Else if ray step Z equals 1, this is forward entry. Then here, this is back plus left. Oh no, this is back entry. So then we start at left. And here we go back plus center. And here we are using entry UV X. So here then is left forward plus center, forward plus center, and right. See how that plays? That does not work. Well, maybe Doesn't seem to work. What did I do wrong? Entry mask Z. Should be right. But it doesn't seem to respect the center. Why is it not doing that? That's why it says enter UV Z there. There. There, now we've got that on both sides. This here we've got the incorrect exit, which looks weird. But honestly, the exit should barely be a thing. It still has to be a thing, but it should never ever render the exit. It should always render the top instead of the inside exit. So the exit should never ever happen. Because the only reason it should ever exit is if it goes to travels to the next voxel. This is good progress. I like it. Now, what you could do now is you could determine how it behaves based on the color, right? So you could have a multiplier on the heights, so that it pushes the lower height up, and well, it's not that easy. We have to apply it somehow to the values overall. But basically you can have like a hardness for each color that makes it smoother or more or less smooth. So if you have like full hardness, then it just looks like this, and it's just super blocky. But then you can have something that's really smooth, and all the lines become just perfect. More or less. At least in theory. And here it's trying. It's trying to actually do what it's supposed to do here, but it's not right. It's not great. It's trying to fill it in. Now, this here is kind of weird. Not sure what I think about this. But here we've got center 2, left forward 0. And here it gets kind of weird. Because even if it is 0 here, it doesn't actually become 0. So maybe I should treat 0 as 0, because otherwise this edge will never touch that edge. So I think 0 has to be 0, and 7 has to be max. So yeah. Go up and change that right away. That's a bit of an issue there, though. One divided. You can't do that. However, what you can do is... Well, not really. But I don't know how big of a deal it is to do division here. And see, that's why it was kind of preferable. And maybe we can do that, I'm not sure, but... I'm so fucked up. Why did that fuck it up? Oh yeah, I know why. I'm dividing by integers. There. There, so now the points can connect. And I think that's probably important. Another issue that we have to consider is how do we get this smooth here, right? Because if I just check like the entry here, it's just gonna be a flat surface towards the center like that. And even if the internals are smooth, that will always look like that. So that is something to consider how to handle. But let's get it to draw this first of all before we start bothering with that. But I think this is done for the sides now. Now we need to figure out the center point. And I don't really know how to handle it. Well, it's not done. We actually have to take our entry UV code and go down to the exit. Oops, this is not the exit. What's going on here? What's this? Oh yeah, this is back entry, forward entry. And here the exit starts. So here now it's gonna be right plus back and then right plus forward. Because we exit right. So this is gonna be again back, right, right, forward. That's all we need to do. I think this needs to be exit UV. Did I do like the worst copy paste ever? That's another error. Ah, whatever. Let's fix that later in one go. So this needs to be forward plus left. No, this is gonna be left. And then left plus center. Left plus center. No. Forward plus center. Then forward plus center. Right. That's what it's gonna be. There. And now this is exit UV. In this case it's Z as well, exit UV. Now this is supposed to be X. XXX. And then here, exit UV Z, Z, exit, exit. There. Now let's see what happens. I don't think this is good. Maybe I'm wrong again. The here it says forward plus center. But I think it should just be forward and no times 5. This is a really big change, but that's this. Well, okay, calm down. No, it's right. Center should always be removed. This is wrong. Back, left, left. Or no, that's right. That's right. Back, right, right, forward. Left, forward, forward, right. Left, back. Back, right. Right, forward. Or back, back, right. Right, forward. This is midpoint. Don't know what to do with that. Back, left. Left, forward. Man, I'm not sure. don't think this makes sense. I don't think this makes sense. But at the same time, I kind of want to save it, I think. Because what I was trying to do was... I don't think the calculation is advanced enough. Because if you look inside here, you see you have these purple triangles here on the left and the right, and in here you've got the beige that goes down here, and the reason for that is it's the left or the right, I'm not sure which. So it goes towards 0, right? Which is forward. So it ends at 0. But here, now this is... I'm not sure, I think this might be back. Oh no, this is forward. So it starts at forward. Or this is forward. So it starts at left, which is 2. So it starts there. And then it goes towards forward, which is down there. And then it goes towards right, which is up there. So what I was trying to do was I was trying to blend it with the value that's over here. But I'm not sure that is accurate either. We need to calculate the midpoint, because I feel like I'm putting too much significance on the entry point. I feel like here, I feel like the entry point should just be forward, for example. Like entirely just forward. If we are within forward, then we're good. That makes sense. But at the same time, that's not right. But at the same time, it kind of is. But the entry point... Now, technically, we don't really want a side entry point, like at all. That's what I'm thinking about. Because here, for example, why should this entry result in a ray hit at this pixel? It kind of shouldn't, because on both here and over there, both of these sides just have empty voxels here. So here, this entry should just be plain along the entire ground. And that's what's a little bit weird. But at the same time, if we have ground like here, then we want it to do that. Because then we want the entry to be tilted so that it's based on the ones that are next to it. But I think I might be doing this slightly wrong. Just a little teeny tiny bit. Because what I'm doing is I'm setting the center volume, which is the volume of the voxel, right? But then I'm setting the volume of the voxels next to it in a plus pattern. And then I'm kind of just using that to calculate how we, make these edges. But it doesn't really make sense for calculating the corners. So what I'm thinking is Maybe instead of setting this volume, that volume, that volume, what we should be doing is we should be setting the corners here, which is relatively obvious if you think about it, because that's how vertices really work. So basically we should be setting these vertices, and what we have to do then is we have to set the heights, and then we have to, for each voxel, we have to calculate, we have to add all of these together and then divide by 4. And that's going to be the corner points, right? Because that way, at least I hope we don't have to have both the corners and this. But that way we can tilt it in that direction, and then using the center we can elevate it or lower it, making it have a shape, right? So it's not just a flat square that's tilted. Which might also not be entirely necessary, but the center, I feel like the center is what, like it's needed anyway to set these points. Might as well be there. Does that make more sense? I kind of think it does, because then if you were looking at one of these corners, for example, then here we'll know that this corner is 0. Well, is that what it'll end up being? I think so. No, it won't. Because this is 2. So it'll be, this is 0, 0, 0, 2. So it'll be 2 divided by 4, which is 0. I guess. And then this corner up here, well, it'll rather be, in this case, it'll be this corner then. See, this is what gets a little bit tricky. But I think we just have to do what we're doing already. So if this, what I'm doing is if I'm checking this block, right? And if I check this block over here's volume, if this is not a surface tile, then instead of checking like this tile and this tile, or adding those two tiles together and getting the average, I just set this volume to this tile's volume, because this is not a surface block, which means it's a full block. So we have to do the same thing here, where I guess if any of these basically is a surface block, then it has to be maxed out to the surface block's height. Something like that. But it's still going to be the same code here, actually. This is going to be... we're still going to check left, right, forward, back, I think. But... basically back, right, left, back here. These are going to be replaced by northwest, southwest, southwest, northeast, southeast. I think. But even that, I'm not 100% certain about. And I want to undo this, but I'm not so sure I should. Yeah. I'm just backupping right now. We go. Now it's back to this way. But again, see... this here, for example, this red, right? It should have depth somehow. So that's why I'm not entirely sure we are doing this correctly. I'm thinking it has to be something a bit more complex. So we need to figure out how to tie these vector points together with the center point, more or less. Maybe we need to triangulate it. Just like treat it like that. Because what we need is we need to calculate a depth, right? So I don't really know how. But we need the center. I feel like maybe I'm overlooking some data here, because technically if I have a 7 here, which is max value, we also have a 0 here, right? So I could here calculate a triangle based on the midpoint and the top point here, like this. But then the problem with that is that I don't know this kind of math. So we have a triangle there, and then have like a triangle here. Well, does this make sense to have a triangle like that? No, but I don't feel like that should be a value. This should actually be... This should look more like this. Like these lines should be like this here. And Then we have lines like this. Or maybe we start there. This is the entry point down here, and that's the exit point up there. So this should go down to the center. This is the center point, I guess. This should also go into the center point. This should also go into the center point. This should also go into the center point. This should also go into the center point, and that should also go into the center point. Does this make sense visually? Because here, this is the one that gets kind of weird, right? It starts at the same value as there. Wish I had a cube to deform. I can start Blender, but I don't know how Blender works, so I don't think I can even manage to deform one vertex. Let me select a vertex. Robert, help! Convert to curve, set origin. Scale, rotate, move, object mode, edit mode. Select. Move. Does this make any sense? Now, this should be... It doesn't have enough triangles. Does it? No. This is not right. Because now you get this, right? And that would have a... That would have extra vertex, an extra vertex point right there. It goes down there. So how do we add cube? Extrude vertices. New edge face from vertices. Shear, smooth, mirror, snap, merge, split. No. Separate. No. Dissolve the vertices. Nope. Subdivide. Oh, there we go, maybe. Yes. Kind of. So now, can we delete some vertices here? No, don't do that. Does that not work? Ah, whatever. We can make do with this, I believe. So if we take this and we move it into the center, then we get that. And what is it that I'm trying to do here? So because we have the entry point and we have the exit point. I think it kind of Maybe it does boil down more to the exit point. More than the entry point. So if we have southwest and we have southeast, then we know the level of the land, right? And if we then use those two as the entry point, then after that, all we need to do well, it's not entirely true. What we can do is we can make a check to see if we are within the exit point. And if we are within the exit point between our other two corner vertices, that means that regardless of whatever else, we are still inside the box. But if we exit on the exit point, what we have to do then is we have to calculate based on the center point if we bump into the contents of the block. Because the center point might be higher. And that's where things get a little tricky, because well, maybe not. But also, yeah, kind of. So I'm just thinking, how would the math work? But I think it kind of works the same still, because let's say we have a square here. Right? And it now looks like this. Like this is the way it looks. And then we have a ray that comes in like this. Or even straight makes it even weirder in my brain, at least. So now we have an XUV here of, like, say 0.2, right? And now we have to figure out on this line here, where do we end up? And what's weird about it is that this is an angled line now. So if I use this, yeah, see. But maybe it doesn't matter, because what we need to find out here is, do we make it past the center? So what we can do is, if we successfully enter, but we unsuccessfully exit. Or no, we successfully exit as well. What I think we can do here is we take this corner and this corner, add them together, and divide by 2. That way, if this is 0.5 and this is 0, then we get 0.25 here. And if this middle point is like a 1, then we add them together, we get 1.25, divide them by 2, get super annoying value, 0.625. In fact, I'm not so sure that even is necessary. No, because what we need is we need this midpoint value. That's what we need. And then we just take our entry point value and our exit point value, and then we divide that by, we add them together and divide by 2. 0.3, that's 5, and then we now have a 0.25 midpoint value here. And then we just check along this line here from 0.25 to 1, and we see if we make it past this height value at our 0.25 y value, or at our midpoint y value. I think that could work. But that still doesn't quite help us entirely. Because we still don't get a precise point of impact, right? We don't know exactly where we hit. We're only checking if we made it past the midpoint. So how do we, that's where the real complicated math comes in. How do we figure out where we hit? You can probably figure that out by doing something like this, this here. Yeah, what I think you can do is, since we have calculated that we did not in fact make it past the middle, then you should be able to calculate here using this value down here and the mid value, right? So how would you do that? We would need to... I would need to be able to figure this out. Like, we know that we can't hit here, and then we need to get this this angle. Because then along this line, there's going to be a point where this intersects, and we might be able to figure that out by getting some kind of differential here, because we can see how far in we've penetrated, right? So when we check this midpoint value, we'll be able to see exactly here where we hit, if it's like 0.6 or whatever. But I don't really understand the math for that, if that's even possible. So if we have that there, how far in we've penetrated. Then maybe we can figure out where we are here. Somehow. But based on all of this shit, I guess what we need to do is, first of all, change our volume to be corner-based instead of side-based, which makes a lot more sense. It also kind of bakes more information into the sides. And that means we have to go here. And here I set surfaces, and then down here, this is what we need to change. This is where we check the voxel, the volume contents. So this is going to have to be expanded quite significantly, which is going to be super, super annoying. But basically here, all I'm doing is I'm checking if the voxel to the in front of us is a surface or not, and then I'm setting something. If it's a surface, then we combine the volumes and divide them by 2, and then we add that. Otherwise, we take the side's full volume and just add that. And we kind of have to do something similar, but this time for every corner, we have to check 3 voxels plus. We have to check. Yeah, we have to check 3 voxels plus our current voxel. And that's going to be annoying. And I think I'm gonna go for a little walk before we start with that. I need to go to the store and buy milk so I can have tea for the rest of the week. I don't know. I hope this makes more sense. I'll be back in like 30 minutes. See you then. We're back. Now, so I was thinking about this a little bit on the way, and basically this whole section, this I'm gonna ignore. We're only gonna do this. So, and the reason for that is because these are the edge voxels, and I don't really feel like dealing with that, so we're just gonna leave those there. But this is actually not correct. This is bugged. This needs to have if wx equals 0 and or that and wx equals walls dot get length -1. It needs to be like that, otherwise it'll actually ruin the it'll ruin every x equals 0 and x equals 63 on every single every single wall. Well, no, that's not true. Can't have the window open. Today is the stormiest day of the entire year so far. Ooh. Because yeah, it does go in here and it checks if that, else it does that, so it's fine, but for now we'll still ignore that, and we'll only do this part down here, because this part is where all voxels are calculated except for the edge voxels. So basically, it's gonna have to work fundamentally different. We're gonna have to do this. Here. Because all we're gonna do the we're gonna do the whole voxel in one go, kind of, but also not really. So where do we start now? Southwest? Three equals southwest. Six equals northwest. 9 equals northeast. And 12 equals southeast. So how do we need to do this now? We're checking if this is a surface. Yeah. Then we basically have to just do this, I think. If any of the three is a surface, or is not a surface, then this happens. But if that's not a surface, then the volume contents just needs to be set to, well, it's a little bit tricky, right? So southwest, that means we check down, check down left, and we check left. Right. If any of those are a surface, then nothing. But the problem with this is it needs to be, well, we can have an internal check here as well that does the same thing, except it checks. Is, let's see, color index. What we can do is we add all the color index indices together. And if that is greater than 0, then we'll set the volume content to 7. And the reason for that is this means that one of the walls is not air. And if the one of the walls is not air, then we set it to that. Else, we set it to, this is a tricky one. Now we have to set it to 0. Except we don't need to do that. Set bits to 0. Right. Because this is only needed later if we alter things. Right now we're just trying to draw it once and be done with it. And then here now we need an else. And what is this else going to do? This else is if none of the sidewalls is not a surface. Yeah. So this is gonna be like that, plus let's start with down, down left, left, and the current one. All added together, divided by, multiplied by 0. Well, no, if we multiply it, then it turns into a float. Divided by 4. That's 1. I think. There. And then the bottom left one is going to be -1, -1, +1, +1. Do like that. Shit wouldn't fuck up over my formatting all the time. Up! There. So now we change this from down to left. Well, it's this, in fact. Like that. Northwest. Let's see. This is now northeast. And that means this is a +1 Z. +1 there, and this is +1. So the whole Z here, you comment out. And this should now be semi-done. The difference, the issue being here, these X's are doing things, but I think I'm just gonna comment this out and just let it do nothing. While we figure out the math in the shader. Now it's gonna behave way differently. Assuming we even got it correct. Which I'm not so sure about, because this but it might not be too bad. Let's change how we read this. Center left is now southwest, forward northwest, right east, and back is southeast. So now this is reading maxed out everywhere except for northwest, which I guess is over here. And it's technically correct, but we get that spike up there too, for whatever reason. But they're not right anymore. We have to go back into the code. See, this is wrong. Just straight up wrong, because how do we do this? Because right now it's kind of reading the air as a full wall. maybe we need to do this, and like that. Well, let's see if that works any better. Here something is wrong, so we've got it's either southwest or northwest that's wrong. Looks correct. They all look correct. Well, no, we do need to do all of them. Like this one. This is just straight up wrong, isn't it? Yeah, so... But here, for example, if southeast is 1... Now what we should do... We should change the colors in here. So what we should do is we got our entry points, and this is X. That's red. So instead I'm thinking we just make this green. Or like a shade of green, like green, reddish green, 0.5. And then on the other side, we make it bluish green. And then we make exit mask. Let's just make that black maybe. And back entry. This one I want to be pure blue, and it is already. And forward entry should be pure red. That way it looks more like a compass. We might be able to remember it better. And then we have an exit mask. We got exit mask right. We made that 0.5 there, but let's make it 0.7 and 0.2. That way we can tell this is the exit mask right, but it's the exit mask because it's slightly brighter. And then this is exit left. So that's green, blue. And then we exit exit back, right? No? Raise step Z is back entry. Left, right, back, forward. Exit right. Yeah, but this is exit left. How do I want to do that? I want to color this so we know which side it is. I think we have to do that. We like flip it here. And that means that this is exit back. Yeah, so now we know that we are looking at the back here, and we're looking at the front here, right? And here this is green, like that. This right. Green, red, green, blue. No. So if we're looking at the front here, and we go over here, then that's the left side. That's the right side. Left, bluish. I just feel like right and forward just feels like more dominant. So it feels like it makes more sense to have those be redder. There. Now I can kind of understand this better, I think. So, what is going on here then? This is then southwest is 0. Yet we've got a big spike there. Yeah, let's go in and actually fix the math then. And by fix, I don't really know what I'm doing, so... The entry points should now just be... Just left and right. Right? We shouldn't bother with the center for the entry point whatsoever, I think. No, because then it might mismatch with the one next to it. So this is just going to be back, forward. So we have to change the way way we've named them. So we have to do this. left to I don't want to have to type too much, but I don't like just SW either. Left forward is now northwest. Right is now northeast. And back is now southeast. So here now, this should just be southeast. Southeast, northwest. That looks like it's super wrong. Now what we want to check here is we're entering. This is actually wrong. This is left entry still. So because we're entering from the left, we need to check southwest. No. Northwest to southwest. And we delete this. And then this is right entry. I could call it east, but whatever. So then northwest, southwest. Then this one should start at northeast and go down to southeast. I believe. Then here we step southeast entry. This is back entry, right? And get rid of this and that. Then we do southwest, southeast. That sounds right. Perhaps? Forward and entry. I should call them north. North-south instead of forward-back. Well, whatever. And then this should be northwest and northeast. Let's try those. Well, it looks like I fucked up. For example, this is forward. It should go from northwest to northeast. Northwest to northeast. Did I say? Northwest to northeast. Oh no, it says northwest to northwest. Maybe I do need to change them. Those are kind of similar. But yeah, now that looks more correct. I still don't think this is quite correct though. We gotta start right there anyway. Now those are right. The blue is right, but the left is wrong. There, see, now we have something there. Yeah, so let's set up the exit points correctly. But the thing is, the exit points are not interesting. We do not want to know the exit point. What we want to know is the collision point in the middle. But let's still fix the exit points. Exit northeast, that means I honestly don't really know what I should put here. But I feel like it should be it should be the opposite side as it is up here. So this is southwest northwest, so this should be southeast northeast. Yeah. So we are doing this. Southeast, northeast. Whoops. West, south, southwest, and exit southeast. No, exit northwest. Southwest, southeast. Northwest, northeast. Southwest, southeast. There. Now we get on there. So that would be then east internal or right internal. Exit mask, exit right. Southeast, northeast. Southeast. That's northeast and southeast. But like the it's not quite correct. Because here we've got, we're looking at the north side and it says northeast 0. And clearly northwest is 0. Did I name them incorrectly? Or what am I doing? Or is this the backside actually? Am I facing north now? I have a negative FOV. So if I have a negative FOV, that means we are looking at the north side now. right? This should be south. No. If I have, well, yes. If I have a negative Z FOV, that means the camera is looking in that direction. So the camera is negative, meaning it shoots a ray with it shoots a negative Z ray. Meaning we should hit forward. I'm so confused. Why is that? Why are these two flipped? They shouldn't be flipped. Let's look at the bricks. Am I using the wrong logic here, maybe? Here's how I was seeing it. If this is the southwest corner, then we go negative Z, negative X, negative X. And that's southwest. And it is it's the one that points southwest, yes. And if I shoot a positive ray at it, a positive ray travels upwards in Z, and then we hit the back first. Just like this, we are shooting a negative ray. No. Traveling in this direction means we increase our Z, which means that this is the south facing. So this is correct. This is south facing. However, now when I move left, we increase my X, which kind of pisses me off. Because now it says southeast. But that is southeast. Like, it's correct now, isn't it? No, it's not. So we do need to flip. We need to flip this back. I thought it was weird, but... Now, this says southeast. Because you have to look at it like a compass, right? Like that's north. That's east. That's west. And now looking at this, northeast is 0, so that's correct. So let's go back and unflip that. That's the left side. Or rather, this is west. So now that's north. That's why we see the south side here. So we're looking north now. Now we're looking west. That's why we see the east side. Looking east, now we see the west side. Looking south, now we see the north side. So this should be correct right now. So now, what is incorrect here? That is an exit mask, and it is one of these. It's this one. So it goes southwest, northwest. That should be right. But it says 0.5. That's not right. Not right at all. There, now that's correct. Anything else that's wrong? Yeah, this is weird. But I'm not sure how I want to handle it. I feel like if this is this is the northeast and the southeast, right? So if we're checking, let's say, northeast, and in this case, both this voxel, that voxel are empty, right? Both of these are empty. And then it checks over here and it's like, yeah, this one has something in it. And because of this side here becomes elevated, so we can hit this despite this side clearly being at the edge and should probably just stay at the edge. But I'm not sure. But like, that's what I feel like. Well, it is kind of matching with those, but it's the issue of how to smooth it. Because this should be like a smooth wall or a smooth section here. As you can see, it's just a 1-1 ratio line. Like it's just 1 pixel per step, more or less, or 1 voxel per step. So it should just be a smooth line like this. And the bumps on it should be based on the center. So maybe rather I have to check, like, if we go over here to make it easier for my brain. Hello, creator of God, how's it going? Here, for example, here everything is pointing south. So when we are checking, let's use this one. Here we get southwest 1 and southeast 0. But what I'm thinking is that while we are checking all 4 per corner and then getting the average, I feel like I should check when I'm checking northwest. Then we should check west and north, and if either of those are empty blocks or a non-solid or a non-surface solid block, then those should be either 0 or max. Is this a game? Well, it might be at some point, but not right now. Right now I'm just trying to render some voxel terrain. So that's the only way I can think of that making proper sense. But is there anything else we want to do first? Now let's fix that. So how do we do that? So here we are southwest. Then we wanna somehow just check if we wanna check south. We should be able to do something like this. If south is not a surface and if west is not a surface, then what we'll do is if either man, this is tricky. At least tricky to do this in a smart way. But then the non-surface takes priority. Like, the fact that there's a surface next, or a non-surface next to us, is the #1 important thing. Whether that is empty space or not. And a non-air, non-surface block is the highest priority block. So this here should make sense, right? Like this is right. If any of the corner blocks are not surface and are not an air block, then the volume content is maxed. That's it. So it's the else that we need to expand on. So if there are no non-air, non-surface blocks, then we need to determine if there are air blocks. But an air block not doing vacuum blocks. How does it? Does it matter if the diagonal block is empty? I think it matters, yeah. So then we do that, and then we do else if Whoa, again? What? Thanks. For like the third time this month. Last time I hadn't been using Twitch. Let's see here. Now this needs to be equals, equals, equals. And then this is just gonna be 0, really. That. And then we need to add this to every one of these. What now? So now we get zeros here on the edges, and these are straight blocks here. Now I'm not entirely convinced that I shouldn't involve the central block here, but I don't think I can anymore. Because if I alter the sides based on the central block, or the central volume, then it's gonna be fucked up between these. But it's also gonna be fucked up now. Shit, how do we do this? I don't know if I can do this with either. Like, I might have to have everything. I might have to have every side. Because, see, the issue here now is that we have a voxel here with a central volume of 0. Yet the northeast and the southeast sides have a volume of 7. So how the hell do I render that? Like, we basically have to just make it super, like, super shallow. And that's why I'm not so sure if I want to keep volumes with 0 volume like that. It's a little bit on the rough end. Um, but it could be averaged. I think. Like, the way I'm doing it right now is I'm generating the world using Perlin noise, and the Perlin noise is a float, so it might be like 6.9 or 6.3 or whatever. So I take the 6 and I use that to determine how high we write, and then I take the remaining decimal, and that determines the volume of the voxel, or of the next voxel above even, and that might end up being like 1, you know. So you might end up with very, very low. But the Perlin should be like relatively kind of surprised it's a 0 here. Here there's a 2. You see, like, it goes from 0 to quite high, or right next to it. That's what I'm saying, like, a surface or a block that isn't a surface might still need to have its stuff adjusted, because otherwise you do end up with voxels that are like sticking out, like over here and over here, where you get like big squares. And yeah, it's I'm not sure how to handle this. Because if I just leave them like this, right? Then this that's got 0 center volume, it's gonna end up looking like, even if I try smoothing it, it's gonna start looking like this. Like at best. It's gonna look like that. You know, like that. And then this right here is just gonna be like that. And this just looks really stupid. Like, this is what it's gonna end up looking like. And that's a big problem. But even more so, if I don't fix the sides being just straight, then it's gonna look like this or something. You know, and over here too, we're just gonna have a big side here. Like that. And even if I smooth this, it's just gonna be like a... This like goes up there, and then the next one goes down as well. Ooh, it's a bit tricky. And like I said, if I base this line here on the center, then if this is 0, then it'll look like this. And then if this one over here is also trying to render, but that one has like a 5 in it, then it'll end up looking like that. And we get a big, nice slope over there that looks like that. Which also makes no sense. And I can't smooth those. Because to smooth those, I would need to know this volume's, or this voxel's volume. Which I can get that by just getting that voxel. But I don't want to get voxels. Unless I have to. Maybe it's not that big of a deal. Maybe I could just read the voxel. Because that means we basically just have to read one voxel for a side, because we're heading out that side. Because we can check which side we're heading out, and then we need to check that voxel to see what the volume is. I think that might be okay. What if we do that? Here we do voxel, get voxel, map position. And then here we do exit mask, etc, etc. And then we can do voxel is voxel data exit voxel equals get voxel map position plus float plus int3 mask times 1. That way we get an exit voxel, and it undoubtedly really affects the frame rate that much. Nah, it doesn't really seem to affect it at all. But I am tricking myself a little bit right now, maybe, because I'm running a map that's only one wall big, which is super tiny, so it just runs better than it's supposed to. But it still doesn't really seem to impact much. So we can get that volume that way. Stop fucking this up. But that's gonna be a big problem. Because if I alter the way the ray exits a voxel by using nearby voxel volume, then it's going to skip past that voxel and it's going to find another voxel and enter that voxel. And if it does that, I basically have to get the adjacent voxel of whatever we're doing. So for an entry, I have to get the entry voxel, and for an exit, I have to get the exit voxel to get those volumes. That's not vcont, that's going to be exit voxel dot volume contents. And then we need voxel data entry voxel equals get voxel map position plus int3 mask times, but 1 isn't good here. It needs to be times ray step. But then a ray step needs to be negative for the entry. Let's see how badly it runs in a more realistic setting. This is why I made it run small, because now that I'm doing all of these checks, it runs like dog shit. That's a lot of purple. Move faster. There. So yeah, it runs kind of poorly here. 200. It would run kind of like this, I believe. $260, $215. See, here it makes a lot more sense when the everything isn't so super steep. But it still doesn't make sense. Because the subsurface blocks also need some adjustments. Because now it's like, you get like these voxel plateaus, just like you do normally. But they're just kind of smoothed a little bit on just like the edge. I think. I mean, not necessarily. It might look okay. We should try to get it working just so we can tell what we need to adjust, really. But here, when I look at this, I get a bit worried. But now that I look at it, if you see, the greens are the ones that matter here, and they're honestly quite decent. Like here, for example, this might kind of suck a little bit. Get a little square there with no volume. And this is weird. Like I have a surface volume here with 0, 0, 0, 0, 0. And we get those a little bit, so that's a little bug that we need to deal with, I guess. So maybe we don't fuck around with the neighbor voxels right now. Maybe we try to figure out the midpoint math. Now, yeah. Yeah. Here we have midpoint math. So, how does this work? Well, I don't know, dude. But we do need this, the midpoint UVZ. I do still think that's correct. So what we need to do is we need to start with getting float to midpoints equals float to, then it's gonna be southwest. That's gonna be southwest. It's southwest and northwest where we enter. So then get the southwest. We need the plus southeast. Yeah. Divided by 2. And to get the other side, which is northwest, we need northwest and northeast divided by 2. And the y min max. What is this gonna be? It's gonna be this should actually be down here, because it gets used for both midpoints. So now, if the midpoint UV is less than 0.5, then we're gonna do midpoint x plus center times 0.5. No, midpoint, it's just that. And then this one is going to be midpoints dot x plus center. Right now. It just goes to center, right? And then we see if we are below that. And then here it goes from center to midpoints y. And that should do something. Got to set the map height and stuff back. See, we do have something. I don't know how correct it is, but we do have something. And now, the tricky part here is that if I look down here, it looks weirder than it is, because in reality, these should probably all be brown. However, I don't know if it's as simple as just setting this to be brown. Because as I've mentioned, what we need to do is we need a point. Like, we need an actual value so that we can get light. But we can try this. I don't know if that's right. See, now we have the same behavior from both sides, I think. Something similar. But see here, now in reality, because we are hitting all these insides, right? What we could do is we could just set all of the inside colors to be brown. And we would have an actual block there. What is going on here, dude? Center 5? How does it have center 5? While not having anything there. Uh-oh. They're seeing stuff upwards. That's no good. But yeah, see this. I'm a little bit scared of what the hell this is. But basically this is it's just the ghost aura from how many steps we're taking. But it kind of makes me wonder if there are like invisible voxels, which there kind of are. But here's what I'm wondering, if we enter the midpoint and we then just take whatever value is at the midpoint there, after we hit it, and then we subtract that, or we subtract our height value from that, then we might get a value that we can use for light to make it vary. But I don't know. But I think that value is what we want. Because even when I go downwards, if we go down from Y and hit the ground, we still need to calculate that. And that one should be pretty easy because I'm not sure I need to calculate a quadrant there. I might have to. Because it's basically if you hit below the center and like to the left of it, then we have to use the center plus like the x and y there to like calculate the height where we actually hit, I guess. But for now, let's continue. We have our midpoint. Let's put them in here. Not so sure it's correct. To the truth. But seems to be trying. Because the fact is that right now we are only rendering it up to the midpoint, and then after the midpoint we're kind of just leaving it to its own devices. But even then, I don't think it looks quite proper here. I think, yeah, once we are above the midpoint, then it starts fucking up. So basically, we can only render properly above the midpoint now. So if I go above like this, so that the midpoint is within where the where we exit the Y downwards, it doesn't work. We have to do the calculations there on its own. And over here, I mean, it seems to work overall. Some degree. This is supposed to be a surface, but this one can't render shit. It renders something over there that's just incorrect. And this side here, this is a problem. Something is wrong here. That's wrong. Right there. This. Maybe I make more tea. He could be good. Actually, it might not be wrong. I think I'm doing this. I think I have a midpoint piece of code in the exit. And that's probably what's happening there. What I think we're gonna do is instead of drawing a certain color, let's draw the overshoot, if there is any. I think there should be. That might do something for us. But the All right. Yeah, whoa. So, as I was saying, let's try here in the midpoint. It's saying if midpoint uv.y is less than y height. Then we're gonna say the core of a good brown is something like that. Let's do 040202. And then we're gonna do nah, it gets a little bit too complicated. Just make it red. And we'll do float all equals y height minus midpoint UVY. Then we're gonna do that on every midpoint. That wasn't the midpoint. Now let's see what happens. I'm never gonna remember to set that the map size. Oh yeah, there, it's the red there. It does not look quite right. Fortunately. But that one just looks straight up busted. But is that an actual... What is that? We gotta change him back, unfortunately. We can keep the first one. But let's see. It's... What is this? This is... 1.6. 1.2. 1.6, 1.2, 1.2. That's this one. That's the first one. Is that one really broken? Look broken. But again, let's go down to exit. Exit. No, I didn't put anything there. But yeah, it's this one here. So it was, right? Let's just make sure that this is the one that's weird. Yeah. Like, what is it doing? I don't really understand. Plus, we get it from both sides? think I put a little bit too much cinnamon in my tea. But see, what's so weird is we get ray step X here. Well, okay. Fair enough. We're looking at the right side there on both sides. We have to go like up here. I don't even really know what I'm looking for here. That's what we need. In my brain at least, what I imagine it should look like is this here. But what was it that I was looking at that felt so wrong? It's like this one here, center 3, yet when I'm looking out from behind it, it's like we're still getting it like really high, and it's just weird. And if we look here from below, then we also get things really oddly. But like here, it shouldn't even exist. Like why are we getting it there? Does it have something to do with the midpoint? It shouldn't. Because here we have the midpoint UV is entry UV plus exit UV times 0.5. Does that make sense? That should make sense. Yeah, yeah, it makes sense. Hmm. At least it makes sense to my brain, but I'm not sure if it makes sense with the logic we actually need here. Hmm. So how do we calculate the height on the Y? That's what I want to know. If we enter from above, then we do this. But what if we do enter from above? And then exit below. But it's not just exiting below, is it? Because if we enter from above, and we don't exit, I don't feel like the midpoint is entirely accurate for what we want. If we go back up here to this, we set this again. So how will this work? Let's make a drawing. See if we can figure it out. Let's go for 2D logic first of all. Right? And then we make a shape that looks like this. And let's do that. All right. That's the midpoint. And we are shooting a ray that goes like this. So now we want to check, does this ray cross through the midsection? So in this scenario, all we need to do is just check the midpoint. But so let's use actual values here. Now this is 16. 16. And that means that this enters at 9. We've got 16 and the worst, ugliest 9 ever. So I kind of don't like this. Can we use a better value? And with better, I mean it matches our stuff. There, so now we have a 4. And we shoot a ray through. The ray is at 3. And the reason I wanted that is because now we can do 4 divided by 7 is this. Divided by 7 is so. And now what we want to find out is where did we intersect? And how can we use this information to figure that out? We use the depth. I think. Because what we know here now is that currently, in this case, our x is 0.5. Does that make sense? Because if you look at this here, we actually like intersect over there. Well, it's hard to say where we intersect. I'm kind of sad that we used this. It would have been a lot easier using this, where we can see a little bit more exact. But basically, the way I imagine this working is we now take this, this value, or we take this value minus this value. Oh, okay, you just deleted the previous input because it was an error. minus that. Then we get this. Right? And what I imagine is that we simply take this and subtract that. I don't know if that makes sense. No, it doesn't. Think. But what we might be able to do is we know that zero equals 0 and 1 equals 4. Because that's what we're checking against. We're checking against the center, which is 1. And this is 0, which is 0. So if we have that, then we can calculate the x value from the y value. Right? So if we then take four minus this, then we get, that doesn't, does that make sense at all? Is that the, maybe, yeah, maybe it thinks we're intersecting there on that dot right there. Okay, so it might kind of make sense. And then what do we do with this? We do we divide it by 4. So then we get our intersection. We actually intersected at 0.964. Let's try doing it here. Let's go back to the model that I scrapped. Just so that we have bigger values that makes some more sense. So then here we go in at 19 or at 9. Now we need a maximum value. Like here the maximum value is 7. So here 16, this is kind of a midpoint, right? So let's say that the maximum is 32. That feels like a good value. And so now we want to figure out where we are here. And So then we have 16 divided by 32 equals 0.5, exactly. And then we have 9 divided by 32. Which is that. And then as I said, we then take (0.5) minus 0.28125 divided by 16. No, what did I just do? Go back. Times 16. Is that it? No. Times 32. 7. 7. So we can. We know this point. We know our maximum value. And we know how much we are overshooting. So now we can calculate the exact position where we entered. Meaning, how do we calculate this then? So now we have entered, and then we do both values are already normalized. So we have y height midpoint equals color. No, let's see. Well, it's not as easy here. Because here we have created another step. We have a we have another axis. And I think that might generate huge problems. Because what might happen is that the center point that we're checking is actually to the left of the center, but the actual intersection is to the right of the center. And then we don't have both values here. But we only need one axis. We only need to get one axis. And it should be fine, because let's see. We don't even need to like check or confirm it. Yeah, because what we're getting is how far down are we below? So is there an even easier way to figure this out? I don't think so. So we need like I'm not sure the 0 to 16 is a good example, but I'm just kind of making this up as I go. I skipped all of this in school. I've never done this before. I did not do any math in school at all. I just skipped it. That's called humble bragging. Or maybe it's just bragging, I don't know. We need a percentage. That's basically what's happening. the thing that fucks it up is that because we are in 3D, a ray could travel like this. For example, like here, it still exits here, and it still exits in the same axis. And then here, what happens is that we check the midpoint, and then we're like, yeah, we're on this side. All right, so we'll just calculate it based on that. But in reality, it might be intersectioning here. So I'm not really sure how to handle this, because I feel like we need to make have a check here, and then a check here. We can't just do this midsection based between here, because even if I did some other kind of check, like an axis check, where I'm like, yeah, we are entering here and we're exiting on like the left side, then we, you know, check this and that, it doesn't work. Well, what we could do is what we could check here is if the entry point is greater than 0.5, then we're over here, right? So if the exit point is also greater than 0.5, then we only need to check. We only need to check against this. But if the entry point is greater than 0.5 and the exit point is less than 0.5, then we need to check against both. And this also depends on, because we do need to check the midpoint. Because here, if the midpoint, if the starting point is greater than 0.5 and the exit point is less than 0.5, then we have to know, is the midpoint greater than or less than 0.5? Because that'll tell us if we need to check the this axis or this axis first. I knew this was going to be complicated, but it's a lot more complicated than I imagined. Ugh. weeks. All right, no use sitting around looking at it. This is all we can do. So this needs to be greatly expanded now. So this is now this is so tricky. It needs to be like if entry point, or if entry UV dot, in this case Z, is greater than 0.5, and exit UV dot Z is also greater than 0.5, then we do this the normal way that we have been doing it, where the well, let's start with less than here, because that's what this is. This is less than. So now here it says midpoints X and center. And that's correct. However, this is midpoints horizontal? What is it called? Like, what is north and the terms for north, west, east directions? Cardinal directions. That doesn't help me. Isn't there like what's north and south? Latitude and longitude. Which one is which? Longitude specifies east-west position. Okay, but what about latitude? Specifies north-south position. Do I really want to use these words? This is midpoint Now that we think about it, this midpoint, it's always the same, isn't it? Southeast, southwest, northeast, northwest. Yes. And then here we have midpoint southwest, northwest, southeast, northeast. Southwest, northwest, southeast, northeast. Yeah. So these are the only two. So let's instead of having those in each section, let's make southwest, southeast. And then this is midpoints. Z. So, southwest, southeast. No, it's midpoint X. And this is midpoint Z, right? Just one variable there. There. And then down here we have midpoints Z. There. Then we raise that through here and we make it through the beginning. And then here now. If entry UV is less than 0.5 and exit UV is also less than 0.5, then all we need to do is just do the normal thing, right? Else, well, let's do it this way. If entry UV is less than 0.5, and then we do if statements in here. And we put that in there. And then we do if else if exit UV dot Z is greater than 0.5 and midpoint UV dot Z is still less than 0.5, then we first check this And if that doesn't happen, if that doesn't work, then we have to do it again, but this time it's gonna be fucking super annoying. Midpoints Z. And since this time it's the other way around, do we put center there and midpoints Z Y? Over there maybe? I'm not sure. I think it depends on like the direction. And then here, this is now based on not midpoint UV, but the yeah, the exit point UV. The exit UV now times X. No, it's still Z. Isn't it? Well, not so sure about that. I think it's X. Because now we're checking this value. And we do have our exit UV, so I think it's X now. I'm not sure if it's still the exit UV. Is it still the midpoint UV that we want to use? Like I'm going past it like this. Is it still? What do we want to use here? This is the midpoint, right? And that lets me use that there. But then what about this shit? We don't need to use anything specific. We just need to use 0.5. Because this is always in the middle. So if we are crossing over this, then we just need to use 0.5 and see if we intersect. Oh. And then that means we need another UV. That's the midpoint UV. Midpoint. What is it called? What is parallel Something being parallel, that means that they are going along each other. And then there's perpendicular. That means that they are opposite, kind of. Alright, so the midpoint UV is actually a parallel UV. Parallel UV. And then we need perpendicular UV. That's going to be don't think we can calculate that. I'll be right back. No, we can. We can, I think. So what we need to do is we need to take the exit UV, subtract the entry UV, and then we add back No. We take the entry UV and then we add back no. See, the problem is that it depends on which direction we're going that we want here, right? Like the parallel UV it's just whatever. It's just like the middle of wherever we're going. But this needs to be the middle of the other thing. But no, it might be doable. We need that plus the exit UV minus entry UV. That's what I'm doing earlier, right? Like where are we doing that? I was quite sure I was doing that somewhere. Here. The min-max plus entry UV Z times min-max Completely lost my train of thought. Because this here This uses the min and the max value. That's the difference. It uses the values. And then it uses the entry uv.z to get which value we are at. But now I want to use the midpoint of the cube to get a position. So what we need then is the direction. And like it would make sense if these values weren't normalized, but I could unnormalize it. Because like here, if I got a line that goes like this, and I'm trying to get its values for when it's over here, right? I can't just get its direction and multiply it by 0.5. That doesn't make any sense. Because the direction would be normalized. So it would be 0 here, plus, or I would take this position minus this position. No, it's this position minus this position, right? And then you get a direction. But if I just start here and I'm like, yeah, start here, multiply by the direction and 0.5, then I'll just get like half the direction, which is like over here. Something. So what we need to do is we need to take 0.5 multiplied by 7 float, and then multiply this, the direction, by that. That way we can get an exit point here. Or rather, if it looks like this. If it looks like this, then we can get this intersection. That's what we need. So again, we take the exit UV minus entry UV, then we get the direction. But I didn't need to remove that. It needs to be entry UV plus exit UV minus entry UV times 0.5 times 7. I don't like that it's a 7 still. Oh, whatever. That should be our perpendicular UV. There. So now we're doing that. Parallel UV times 2. Yeah. Yeah. Else. Well, there is only one more else, right? And that's exit UV dot Z is greater than 0.5 and parallel UV dot Z is greater than 0.5. And this is where things get fucked up. But it basically needs to be center. And then midpoint Z or Y. And then we need to use our perpendicular UV dot X times minus 0.5 times 2 and then if our perpendicular UV is lower than that, then I still haven't calculated the value that we need to use here. But I think this is basically all. Now, this needs to be done on every step. We need to make this check. However, we also need to determine our actual height and entry point. And to do that, because here, if we cleared this, but we don't clear this, that means that this whole area is safe. So we only need to back up to the midpoint to figure out where we intersected. So let's start here then on this side. So if we enter here and we hit this place and we intersect, then we get a value of how deep we intersected. right? And I've forgotten the calculations. And then we take our depth. And then this is traveling, when we say midpoints X, that's what we're checking here, the midpoints X. So if we take midpoints X, let's see, float, midpoint equals midpoints X on one side, midpoint X plus yeah, what we need to know is do I already have it? We have the Y height. So, and that's what we need. So we already have that. Hello, Tulip. Going all right. It's just complicated math. Hold on. I need to think. So if we have an entry of 0.3 and we have a top value of 0.5, but we have a hit of 0.3, and we have a bottom of 0.1. Then to get the percentage of where we are within this, we have to take do 0.3 minus 0.1 and 0.5 minus 0.1. That'll give us 0.2 and 0.4. And then we can do 0.2 divided by 0.4. And that'll give us the percentage along the line, which we are. Well, yeah, and then we multiply that by 0.5, I guess. And I've done the math like 3 times now, and I still can't quite wrap my head around it. So this is we need midpoints x dot y parallel uv dot y minus midpoints x divided by the midpoints x there divided by midpoints x dot y minus midpoints x dot x. And that should give us the point where we intersect, and then we can do dot intersect equals midpoint times a midpoint dot x dot y. Is that right? Let's look at my thing here again. So we have 32 maximum value here, and we have a 16 height there. Let's change this. This is now like, it starts there. Just to make it not 0. So then it starts at 5. So then we check the midpoint. That's 9. That's 9 and 16. And then we subtract 9 from 16. Yeah, I'm using raymarching. We can use marching spheres to find the closest intersection of the ray with the terrain. Maybe. That could maybe be a solution. DDA is a ray marching algorithm. But how would I use a sphere in this case? I can kind of see it. I just don't know exactly how to do it. I've seen videos on it. I know what you're talking about. But see, this is basically... yeah, I've got 4 points or 5 points. I've got like a center point, and then I have volumes on each corner that tells us how high that up, how high up that is. Let's see. Sphere tracing algorithm. Please, just give me like a... Just tell me how to do it. Don't make me... Oh, I don't want to read papers. Please. It's all like Chalmers and fucking educational Stanford. Yeah, I know exactly the idea behind it, and it might be a good idea actually, but I don't know if it is a good idea in practice. It should be though. Cone, triangular prism. Triangle. That's what I think I want to use. What's going on here? Ah. Yeah. Well, I'm not sure I can use it. I mean, maybe. I should be able to. Have you seen fractals? Not really. I don't really know what that is. Because we do have points, so it might be viable. What I need to know is where we hit inside of this. Hello, Sandro. LSD, I made it. The derivative ft. Okay, what does f mean? Sphere tracing, blah blah blah. Sphere tracing, blah blah blah. Blah 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 blah. Distance surfaces. This section defines and discusses functions that measure or bound the geometric distance to their implicit surfaces. Such functions implicitly define distance surfaces as mentioned in Blumenthal and Shoemake 1991. The appendices derive functions that measure or bound distances for a variety of primitives and operations. Let the function, I don't know what that is, be a continuous mapping that implicitly describes the set. Jesus Christ, look at this shit. Look at this. Let the function be a continuous mapping of. Why are you using retarded R's? Like, why does it have to look like that? Do you have to use like super R's? Can it just be a normal R? That implicitly describes the set A. What does that mean? These are as the locus points. Belongs to that set of numbers? I don't know what that means. I don't know what that is. I don't know what a set of numbers are. In this case, what does that mean? The point to set distance defines the distance from a point x e thingy weird r to a set. Fuck off. This is the only reason math is hard. It's because math nerds are fucking assholes and they just invent new letters all over the place that are completely unnecessary. A double vector? Okay, what does a vector mean? Is a vector a direction in this case? A vector can mean many things. And what's a double vector? How can a vector be double? I don't know what you... A set of numbers. So it's a vector too. It just has like 0 and 1 in it, and or 3 and 5. Nah, you know what? Fuck it. We're not doing that. I am going to look into it, but I can't do that now. I'm not gonna manage to figure out bears and shit. I'll be right back. No, I didn't feel like that. So we're going back to what I was doing here. If I can remember where I was. So we're calculating intersection points. Right? So let's go back to calculating this one again. So this side is 5.
This awesome looking.
Yeah, I've seen something like this before. I mean, I've seen videos on sphere tracing before, but I particularly looked at this. But anyway. So we're casting a ray through here. And then we're checking the midpoint, which is this. This is meant to be the midpoint. Right? And then we the value here is 16 and our ray is at 9. So then we take 16 minus 9, which is 7. And then we take if I just take 7 divided by 16 in this case, then we get 0.4375. But what if I take 7 divided by, or 7 minus 5 is 2. 2 divided by 11. Then we get that instead. Times 16. Then we get 2.9. That's not what we're looking for. We're looking for 7. No, 16 minus 9 is 7. No, that's not what... Yeah, well, yeah, it is. Is it that easy? No, it's not that easy. No, that's impossible, because this could have been whatever. Like, I could change this. Like, I could change this to be like that. Then it would be at 8. So yeah, that doesn't make sense. I've already calculated this. I just need to get my brain back into it. But again, this is 5. Why was I using 7? This is 9. So if I take 16 minus 5, that's 11, and then we get 4 there. So 4 divided by 11, that's times 16. Then we get 5.8. That's still not 7. It's 11. I'm trying to get this intersection here. How did I do it? I mean, it made more sense when this started at 0, but now I'm trying to start it at 5 to make it more difficult. Is it like this? No. 4 divided by 11. Does that make no sense? I'm 16. I'm 32. Basically, we have a volume here, and let's say the volume is 32 in size, up and to the right. So then here we've got a little graph, or whatever you want to call it, and the midpoint is 16. This is 16, and then I cast this ray through it. So at the midpoint, I'm checking if we're intersecting, and we are. And then I check how far down are we, or how high up are we, and we're not. So I'm trying to get the actual intersection point through this differential. I'm trying to get a 7 over there. Because this height here is 7. Yeah, that's what I'm trying to get. So we're using The red line is the volume. So this is 5. It starts at 5, the volume. And as we go further into the volume in the X, the volume increases up to 16. And as we go further in, it goes back down. So this is literally a ray through a mountain, basically. I already did the math here before. Kinda. Yeah, we have, oh yeah, the ray starts at 6. We have that. We actually also have where the ray ends. I just haven't included that. I don't know what those algorithms are. I mean, that's what I'm making right now. So we get 11. I still want 11 divided by 4. No, 4 divided by 11. Then we get that. And then we have 6 minus 9, that's 3. Times 3. And we get 1. And then we have 6 here. And then we add the 1 to the 6. And then we have our intersection. I believe. Unless I'm doing some unnecessary steps. Thank you. Holy shit. No, I can't look at this right now. It's too much. I can't get into that. I'm not gonna get anything out of it and my brain's just gonna fry. Um, but it's basically what I'm doing. So we have the parallel UV. That's where the ray is intersecting in the middle. And then we subtract the midpoints x, which is the starting point of the volume, divided by the max point of the volume minus this the min point of the volume. And then we get our float. And then we need to multiply our ray start value. Its midpoint times where is it in this case? Midpoints x. Parallel UV. This is the first step, so this is just gonna be start entry UV. Entry UV plus that, right? Times 3. What was the 3? The 3 is... no, the 3 is... Entry UV. It's parallel UV minus entry UV. Okay, so we are intersecting here. And then what we do is we take this value on the line minus the value here on this side of this, divided by this value, which is the middle point, minus the value over here. Then we get a percentage, and then we take the entry UV, which is here, plus midpoint, which is what we just calculated, times parallel UV, which is this value minus the entry UV. And then we should get wherever that is, there somewhere maybe. That should be right. In theory. And then Then here we want an intersect dot y to be the color. And then here, what happens here? We have an exit UV of greater than 0.4 and the parallel UV is less than 0.4. And that means we do this. So we just repeat this. And then we need to do a perpendicular check right after. That's gonna be it's gonna be center here and will it though? Yeah, I think so. Center there and midpoints y dot midpoints z dot y. Yeah. And then here we have a parallel UV, but this is no longer what we're using. We're now using a perpendicular UV. And is that dot Z or dot... What are we using? Holy shit. I think we're using dot X now. And then here, if perpendicular is equal to that, then these all need to be perpendicular, and instead of enter UV, it needs to be parallel UV, because that's the last step, I think. Yeah, because that's where the line, or where the ray started last. However, midpoints X, this is now midpoints Z. And now this is the second stage. It's really complicated. Oh. Because it gets really confusing, because when you come with a ray from oh, come on, let's get rid of it. When you come with a ray from down here, I know you're not following. I'm barely following. When you come with a ray from down here and you check over here, you read it from left to right. But when you're coming from above, you would think, all right, we'll do the same thing. We'll read it from left to right, from this point of view. We'll read it from there to there. But no, it reads from the same starting point over there to over there, no matter where it comes from. And the same is true from here. So I'm not entirely sure which direction is which direction here right now. But basically what's happening is, because I have a midpoint, it's not enough to just check if the ray is intersecting here in the middle, because the ray can travel through like this, right? So we have a midpoint, and the midpoint has a height. These corners all have heights. So we calculate this intersection by taking this corner and that corner, adding them together and dividing them by 2. That way we get a height value over here. I don't know if I want to do it that way, but that's how it works right now. And then here we're traveling in the... This is going to be in Z. This is forward, so we're traveling in the Z value here. So that means that we use our ray's X value in the center here to determine where along this line are we. And then we just check that value and we see if our Y value is lower or higher than the intersection's value at that point. And if it's higher, then we continue. But now we have to check this intersection as well, because we are traveling across it. So now we have to check this, and that means we have to switch our logic over from using the X and checking in this direction. So now we're checking like this instead. Oh. We're checking like that instead, kind of. And that's where it becomes very confusing, because we have to determine that one side is the starting side and one side is like the maximum side. And I'm not sure if how it ends up being, if this is the start or if the center is the start here. But it's one of them. I'm just thinking. I think this is the start over here, because we're going from left to right here, and this is the positive ray, like, right? It's going this direction, so it's going up and then reading left to right. Yeah. This is shooting there that way. And then it's gonna be like this here, right? Or is it not? Man, it's so hard. So hard. Like, Y is towards us. A positive Y value goes towards us. And I mean, this should be like this. To be honest. There. So maybe it is actually over here that we're starting. This is the lower value, and then we go up here towards the positive value. Yeah. And right now we are shooting, let's see. This ray is a left entry ray. So it's actually coming from over here. Like this. And it's entering like that or something. And then we check the entry UVZ first and foremost. And in this case, the values start from midpoints x.x to center. And midpoints x is southwest plus southeast times 0.5. So it starts from here. Southwest to southeast to northwest plus northeast. And that's over there and over there. And then I'm getting these points. Because that's our midpoint. And we are starting with southwest and southeast down here. Because we are traveling in Z from Z0 to Z1. Like that. So we start there. I want a ray that goes like this. There. So then we go in here and we start checking the entry, which is southwest and southwest to northwest. So it starts here and it checks to over there. And we base it on this, which is the ray intersection or the ray entry, right? So that's where we enter. And then we just check if this this Z position between here in this is some kind of angle based on this side's volume and this side's volume, and then we base if this the ray's Y value is above that, and then we continue. Otherwise, we return a color and break. And so over here now we have to make a bunch of checks. So if entry UVZ is less than 0.5, that means it's down here, because again we start our Z ray down here and we go up there. If it starts there, then we just make a normal that if it starts there and the exit UV is also less than 0.5, meaning that the ray goes like this, then we know that we only need to check this midpoint, the perpendicular one, which I for some reason seem to be calling parallel. Shouldn't this be the other way around? Well, whatever. And yeah, so now to check this, we know that we are, since this ray is traveling, this is an X ray, so it's traveling using the X value, it goes further in. So what we do is we take the starting point of the ray and the exit point of the ray, and we add them together, divide them by 0.5. That way we have the midpoint of the ray. So that's where the ray is at this intersection. Then we use that and we do the calculation that I just figured out, I think, to get the intersection, or to get the, well, we get how far down we are there. Like if we collide here, we check how far down are we, then we use that and we calculate the correct intersection based on where the ray entered. Yeah, then we have a completely different section there. This is for entering, because we know which side we enter. This is entry mask .x, meaning we are entering in the horizontal. And then we have ray step x, which means we are ray stepping in a positive to the right. So we need to do this for every there are 6 scenarios. And each scenario has 3 different scenarios where they can either just cross one intersection, or no, they do have more. They can just cross like this as well. It might not cross any intersection at all. And in that case, we need to only check the entry and the exit. So there's 4. Like that, like that, like that, or like that, or like that. Either it doesn't cross it, it crosses this first, and then exits, crosses this first, then crosses the vertical one after that, or it crosses the vertical one first, and then after that it crosses the horizontal line. So, those are the options. It is a lot of if statements. Ooh. Boy. Yes. Like that. And then we have the last one there. And this should just be this first. Except this time, this should be midpoints z dot x first there, and then center there. Then this needs to be perpendicular UVX minus 0.5 times 2. And then this is perpendicular minus entry UV. This is minus entry UV. No, this is center. Entry UV X. That's not what we want. This should be well, no. The midpoint x dot x is actually y. Yeah. And then here, how is this gonna work? Because this one might be the opposite. What's the end goal? I'm smoothing the terrain. Now it looks stupid, but you can see these are meant to be the voxels. The edges, kind of. Then I'm trying to make it fill in the ground so that we get smooth terrain instead of square voxels. That's what we're doing. Hope it also works. But I don't think I can continue that much longer. My brain cannot do that much more in one day. Now, where am I? We're doing that, we're doing that. We're doing that. But this is the second bit. And that means that this UV here this needs to be minus center. And this should be midpoints Z. That looks more correct there, I think. And then here, midpoint is wait. Yeah, entry UV minus midpoint X divided by center minus midpoints X. The intersect is the parallel UV, yeah, there. That makes more sense. And here again, we reach the midpoint first, which is not parallel, it's the perpendicular midpoint. Then again, entry, center, midpoints, parallel UV, entry, midpoint, entry, yeah. And then down here, we start at the center and we go up along the midpoints Z's, Y. And that's gonna have to be plus 0.5 there. And that means that the center is the start point. And here now we've already crossed this. So our starting point is now our parallel UV. So parallel UV minus center divided by midpoint z y minus midpoint z. No, that should be minus center. However, this can potentially be 0. What you can do is you can do... No. You basically have to do an if this is 0 thing, I guess. I don't know. Whatever. Something like that might be correct-ish. I'm not convinced though. That's the one that we're checking. Think. It's so hard to tell because it changes shape so much. And it does that as it should, kind of. But it's just all so fucked. And I have no idea if it's doing what it's supposed to be doing. That kind of makes me think something is not right. That little sliver we can see there. Because what this is supposed to show is... It's supposed to generate like a height value, I think. And the fact that that height value is like inverted compared to the rest makes me wonder if it's broken or if that's the only one that works. But here, for example, the center is 3. So the closer to the center that it's intersecting, the more red it should be. Kind of. This one has center 6, so you can see that one goes redder faster than this one, which is only center 2. But I don't really know what to flip around. Is it this one that's not done? Wait, what's happening there? Something like that. This actually needs another stage after this. I think. The others might too, I'm not sure. Because we might intersect from the midsection to the end section. So this might still be... We might still need this third step on the bottom ones too. Let's just play it and see what happens first. And yeah, we've only made 1/2 of one side so far. And I don't think it works quite correctly. Like this this bothers me. I don't really know what's happening there. But that's because it's intersecting, or it's not exiting. It's just going down into the Y. That's why. I think. So it's kind of like this. It's meant to be viewed at the moment. And it's kind of weird there. And it's but you can see yeah, over on the left side it doesn't work quite right. We'll just have to keep hammering on that a bit. I can look up sphere marching and see if I can figure it out. But not 100% convinced I can use that here. No, that shouldn't be needed. We should be exiting. Ooh. But let's stop there. I need to go and make food, and making another one of these for the next direction is gonna be a pain in the ass anyway. Oh yeah, I've only made half of them for this direction. This is if entry uv.z is less than 0.5. So we need to have this again. All of this needs to be copied in again in this ray step. And we have 3 directions and 2 ray steps for each. So this is what it's gonna look like for each direction. Horrible, horrible, horrible. But I'll be back tomorrow. Until then, thanks for hanging. Have a good night.